Good morning. My topic's going to be a little bit different than a lot of the other ones that you're going to see, in that it isn't quite as tech-focused, it's more data-focused. But it's only half an hour, so if you want to get to the polyglot databases, that's coming up in 29 minutes now, which I like, by the way, so I like this presentation a lot. And you just got my background. The other thing on that, my book was never intended to be a textbook, but it's being used by 40 graduate programs right now on the BI side. There's a shortage of BI textbooks in the industry. Kimball was the only one that was out there, and that was really just dimensional modeling, so that's just aside. So we're going to talk, there's a lot more slides that we're going to get into an examination of. They're there for as an FYI to some degree. We're going to talk about the current state of BI, some of the common mistakes that have been made, how to plan for a modern BI implementation, designing the analytical data architecture, and then a little bit about data integration technology, since I think the database stuff is covered by many other presentations. So the state of BI. Now, there are just a few points from here that I want to make. Besides sort of the data deluge and the 3 Vs or 5 Vs or however where they are, some of the differences that I think that have gone not looked at as much is the fact that beyond just social media and unstructured data, lots of the things that are happening in businesses, and that's what I deal with, consulting to businesses and enterprises and implementing analytics within their 4 walls, is that there's much more exchange of B2B data, business-to-business data, and business-to-consumer data. Also that's different is that enterprises don't own or manage the data as they used to do. So before we had the 4 walls, now we're getting lots of stuff that we don't manage, govern. It just has to be blended in with our analytics. And of course, a lot of that's being brought in by business people or data analysts or business analysts without even the IT group knowing, which is fine. Second, there's a lot of local data that actually converts data into information that's useful for business. So still unbelievable, still lots of data in spreadsheets and unstructured documents, which are the business rules, the filters, the key performance indicators, the metrics, the hierarchies that are used for reporting and analysis and even for predictive analytics. And lastly, of course, as you all know, the demand for analytics keeps getting stronger and stronger as more and more people are used to getting that information that they can get on their iPhone, but they can't get necessarily about their company or about their company's sales. So just real quick as a reference point, why we are where we are is because we are built, at least certainly in the US, but outside of the US, businesses are built to be silos. We have business functions, we have business geographies, we have different product groups. Everything is structured to be efficient from a functional point of view. We build business applications, SAP Oracle apps, 40,000 tables plus in SAP, hundreds of modules or submodules, all finely tuned for those business functions, but not necessarily for analytics across the enterprise. Cloud apps, great boom to efficiencies for improving business processes that we never had before. Each of them, again, is optimized for their business processes, Concur, Salesforce.com, et cetera. One of the leading indicators of getting work, my consulting firm, somebody installed Salesforce.com 6 months to a year later. They're trying to get that data in with other information like their financial data in order to analyze that. And finally, there's a big difference between, unfortunately, there's been a big difference between data and application integration in most firms today. We'll talk about all this. Now, usually there's a lead into this slide, but I'll say that in every company that I've been in, I used to be the Informatica thought leader for 3 or 4 years on enterprise information management. They drew this diagram for me a while ago. And every customer that I've had since then, I use this diagram. Rather than diagramming their current systems, I just show this one. Many of my peers have said, you're probably going to insult your customers, but they've always laughed and said that doesn't portray half of the problems that we have in our system today. So this whole idea of an accidental architecture, all sorts of applications, all sorts of attempts at data warehouses, data marts, application integration. Companies have silos, business, and data and information throughout the enterprise. And it's filled in through spreadsheets. Despite whatever anybody tells you, how many Tableau licenses are sold, or Cognos licenses there are. Spreadsheets rule the day. Now, Boris, who I know I used to work with at PwC, says 50 to 80% of all analytics are done in spreadsheets. I'd say it's 90 plus. Nowadays, it's probably hidden because lots of what Tableau users are doing is reading Excel spreadsheets and just doing better visualizations out there. Now, why that's important isn't so much that Excel is a bad thing, but Excel, and what I'm going to do in the next slide, is the data superglue. It masks this accidental architectures and masks the fact that people don't get the appropriate analytics types or tools or processes to support their businesses. And so this idea of spreadsheets becoming data shadow systems. For the Data Warehouse Institute about 10 years ago, I did a research paper with Wayne Eckerson on data shadow systems. And we found at that point that enterprises had about 30 data shadow systems. Now, data shadow systems was in the spreadsheet. It was probably hundreds to thousands of spreadsheets used to do analysis. I don't have the time. I can go when I teach this in class or at seminars, I can rattle off X number of names of these at major corporations, but I always mask the name because they're former clients and they certainly don't want to be embarrassed. But large firms that are using this. Now, nobody starts to build a data shadow system. Somebody builds a spreadsheet. They get the right answers. Somebody adds to it. And next thing you know, you got 100 tabs. The first 50 query different databases. The next 25 merge them together. And the next 25 does reports. And nowadays, then Tableau reads the data, and you get great visualizations. Now, the problem isn't the spreadsheets. The problem is the use case. And that's reporting is fine, but Excel isn't an ETL tool or a data integration tool or an application integration tool. And business people, jobs are not to do data integration. They can do data prep, but they're not to integrate data across an enterprise. So that's one of the problems we keep encountering all the time. And the state of the system is like this. We have lots and lots of investment in BI, hundreds of billions of dollars, tens of billions of dollars a year going into BI tools, data integration tool, application integration tools, Hadoop projects. Every new technology is yet a new data silo for my company's fix after the first wave of hype goes on. Now, that doesn't mean that those technologies aren't great. They are, but they tend to have a tendency to create another silo. Let's talk a little bit about it. First off, US, we're technologists. Society, we figure everything can be solved by the next great technology, AI, machine learning, big data, whatever. All those are great tools, but as Gartner has the hype cycle, we realize that the expectations are higher than what you can get out of them. And it's mainly because the use cases are not to fix everything in the world. It's to answer certain particular problems. So I'm a huge advocate of polyglot databases, machine learning, AI, all that stuff. But I'm suggesting to you that it's only part of a toolkit that be used in an analytical data architecture. The other thing that we have, and this is a little bit what I alluded to with the spreadsheets, is that we fall into the one trap. So we fall into the fact that we think that one technology is going to solve all our problems. We keep hoping it is. And when I do this on a longer duration, I have a series of slides where I go through how the latest BI tool is going to do a dashboard in minutes versus weeks. The next slide says in a minute. And by the way, I had these same slides for the last 3 or 4 generations of BI tools, be it Cognos or be it Tableau now or ClickSense. So the issue there isn't the fact that those tools aren't better. They're absolutely better, and we implement them all the time, and I teach them at Northeastern. The issue, though, is the problem isn't the tool, although the tools are very helpful. That means we can get more and more data and do more and more analysis. The problem is we have business analysts and data analysts who are spending most of their time getting the data into Excel spreadsheets in order to be able to do that analysis. The other case is that, and we're going to look at it real quick, is the fact that there's different use cases both for data and analytics. That one tool doesn't fit all. So even though there's a BI tool, there's different types of analytics and different types of analytic use cases that different tools are useful for, or that you could even use the same tool. You just need to know how to design it for that use case. Also that there's different BI personas. Most people, shockingly, most people don't want to spend all their time in a dashboard. Now how cool they are? Most people have a job to do, and that's not creating a dashboard. We have a tendency in our industry to work with data analysts or power users who love playing with these tools, and by the way, build the data shadow systems, but aren't the typical user of information, and then probably aren't decision makers. So, and then lastly, we have a tendency to like to get one vendor, and although there's a lot of vendors I like, usually no vendor has a lock on the technology or the ideas that you want to use. So you do need a mix of things. I think that has been broken to a large extent, but for a while, in my tenure, last 30 years doing BI, lots of companies were gearing in on one vendor to do all that they wanted to do. And they could only buy so many companies till their suites got to be ungodly slow and difficult to use. The other thing that's ironic in here is the fact that one of the worst things that we've done in IT is we've created our own integration silos. So typically when I come into an organization, they have a data warehouse group or a BI group that's doing data integration, Informatica, data stage, Tableau, ODI, business objects, data integrator, data services, whichever. And then they have MuleSoft or some other application integration tool. Then they have some iPaaS tools. And by the way, they're all taking data from the same sources, applying different business rules, and then their business people get the wrong answers or different answers. Why is that? So it isn't, we have silos to begin with, and then we expand the silos and exacerbate them with the fact that we haven't coordinated our integration efforts. We can at least excuse the business users because that's not their job. They're just trying to get their job done. But IT, our job is integration, and those efforts should be coordinated. Lots of times we get into a large company and we're working behind the scenes with the IT group to try to coordinate their integration efforts. Not that they have to use one tool, but they have to coordinate the use of the tool so that they have the same business rules and definitions when they apply across the board. And the other thing is as IT, again, business users can use ETL, but I'll suggest that although most large corporations use a ETL tool or data integration suite in order to load their warehouse, then almost none of them use that tool to load their data marts or BI schemas. And I'll suggest to you most of those are flat file data sets that they need normalized. So we continue to do more and more kinds of things to ourselves. All right. Trying to look at the time. And the last thing is, since I've been doing warehousing for so long, is lots of the work that my firm does and lots of our peer firms do is sort of assessments, BI assessments of what people have gone wrong on. I'll suggest to you that it's very rare for me to see a warehouse that's been designed even close to best practices out there. Many different reasons, we don't have time to get into them. Big bang, waterfall projects, a centralized third normal form or ER data warehouse. Did some consulting to SAP and their third or fourth iteration of BW. All application vendors have an issue of trying to replicate their schemas and their processes in their warehouse, and so does IT. And that usually doesn't lead to an effective warehouse. The next thing is the fact that people have a tendency to do operational reporting or data mart silo focus when they're doing the sort of the Kimball model, or at least what people perceive the Kimball model to be. I suggest to you they didn't read all the chapters of his book, but they'll use Kimball as an excuse for that. And finally, there's just a general misunderstanding of what the whole idea of an architecture is when it comes to data, schema, stepwise refinement of the data, et cetera. So that's what we'll talk about real quick here coming up. So things to do. First off, BI is not just a connectivity issue. It's not just querying the data. Information is data in context. This is one of the key things. For a long time in the industry, we had a single version of truth. There is no single version of truth, okay? You can record data and make sure it's correct from the source systems, so that could be considered a single version of truth. But taking that data and interpreting what it is in the business context. So Partners Healthcare and Mass General, how many people work there? Do you include doctors? Do you include full-time people? Most physicians are not employees. Do you include the people on the first floor that are in their physicians' offices and not in the operating rooms? Do you include the facility staff? Well, lots of questions that mean something. So there's nobody playing with the numbers. It's different interpretation of the numbers. We did some data governance at a large engineering university recently, and their issue is how many people are at the university working. Not an easy issue to answer. We didn't solve that for them because there's lots of data governance issues that they have to work out. So the issue is information is data in context. And sometimes people need the information 5 Cs. So sometimes they can use data as is. Oftentimes the initial POCs or initial BI projects are spreadsheets that people know, or Salesforce.com or Marketo, or some app that people understand pretty well. They point the data to it, it's consistent, they understand the data, and they're flying. But in other times, and this is the unfortunate thing of a warehouse, is they have to deal with old data, dirty data, inconsistent data. That's the tough thing. You know, and Tableau doesn't like it if the column names aren't the same. Trivial issue, unless you're dealing with X thousands of tables from SAP and Oracle and Salesforce, Marketo, blah, 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 Infor, go down the list. So cleaning the data, making it consistent, conforming it, and getting the current data and also as much comprehensive of the data as possible is certainly the nirvana of trying to integrate data. So the information 5 Cs. So first thing when designing an analytical architecture is to understand what data can be used as is, what data needs the 5 Cs, and what data can be curated by a business from the warehouse or from a particular app themselves. And so tools like data prep tools work extremely well, and you don't need to get IT involved. So the key there is to figure out what is your state of data that you need for the application and build accordingly. So I've never thought that all data needs to be in a warehouse. I also always thought that you need a data warehouse, an MDM, or a data hub, whatever you want to call it. We've had clients who call them repositories because data warehouse got a bad name for the first 2 or 3 failures of it. But you need 3 different levels of data. The good news now, as opposed to what happened when I first started in this space a long time ago, is that you can use the same BI tools, the same integration tools, the same suites of database technologies out there for any of those 3 states. So whether it's in the cloud, on-premise, NoSQL, Hadoop, Polyglot, relational, columnar, in-memory columnar, you can use any of those tools. If you want to use MuleSoft, Informatica, Talent, whatever the tool is, you can use that across all those systems now. So that's the good news. Before you had to use tools specialized for the apps, tools specialized for different environments. The great news with the technology you guys are listening to this week, the next couple days, can be applied to all these. So first is to understand that. And so we have 2 suites sort of data. The second thing is that there's different types of analytics. So there's descriptive analytics. That's what most people do. I'm just looking at the time because I only have half an hour, and I want to give a half an hour to Jeff. Descriptive analytics, that's what most people do. What happened, how it happened, year to date, year over year, quarter over quarter, whatever. Diagnostics, that's really what if analysis. That's where most of the data analysts and business analysts play. So they're going to do the what if analysis. Third one we hear a lot about, predictive analytics, and then prescriptive analytics. So those are, of course, more on the data science side, stats, and doing things. Now, one of the funny things, not funny, but several of my customers early on in the predictive analytics phase, which lots of people are doing more and more of, they're terrific. They told me, Rick, we don't have to worry about historical data anymore because we're going to do predictive analytics. I explained to them, if you don't have historical data, then it's a guess, right? If they never, first I asked them if they ever took a stats course in their life because you can't do predictive analytics without some kind of stats. Oh, by the way, I'm very proud. My oldest son is a senior data scientist, so he went to economics and then flipped to be like a customer of mine. He's not a customer of mine, but the people that I work with. Going along with that, we kind of described a little bit about the different types of people out there. Information consumers, 80% plus of the people in business that are using these systems are using them to get information and get out, right? Now, that doesn't mean they get PDF files anymore. They can do filter things, they can do what ifs, they can drill down. They're not like, they don't need a PDF anymore. I mean, people are beyond that to a large degree. But what they aren't gonna do is get a blank dashboard from Tableau and work on a dashboard from scratch. That's what the business analysts and data analysts do. And more of that, you wanna design the architecture so that the data analysts and business analysts can publish both data sets and BI applications for others. So shift more of the work to the business community and the data analyst community, and have IT spend more of their time on this data architecture and data backbone. And finally, we have the data engineers and data scientists. So a few things on there. First off, I mentioned already the fact that we can use we can share tools across both the curated data, our integrated data, as well as the data as is nowadays. And I put on here the T in that we have not just access to the data, but also integration of the data. You know, Tableau, et cetera, are adding, and Power BI, et cetera, have data prep in there. Other people using Alteryx to get to Tableau. Plenty of other great data prep tools that are emerging in the space, as well as the data integration vendors having data prep tools of varying levels of quality or geared to different user bases. But BI can use both access capabilities as well as data prep capabilities to get to this data, both the curated data and the data sources themselves. The other thing we just put out there is the fact that semantic layers are very important. What you want to do is do things once and use many times. So the warehouse or data hub or MDM is integrating the data from the enterprise and even outside the enterprise once and using it many times. The idea of the semantic layer, whether in the old days we would have a physical data mart. You could still do that, but you could have data virtualization, OLAP cubes. You can, most things, you can have services, microservices, views, lots of things out there. So there's lots of different ways to encapsulate and propagate the use of the semantics, the business rules, et cetera, without necessarily physically creating a data mart. You can use data marts, it's no problem, but there's lots of different ways to be able to propagate out there. They're getting more and more sophisticated, and a mix of those is pretty useful. The idea is that we don't need the business user to go from a blank screen. If they point to the semantic layer, et cetera, they can work from there. All right. Going back to curated data or integrated data. So the old school hub and spoke, this is sort of, at least from a high level, we're talking about a BI schema and a data warehouse schema. The idea going through here is that you have the former warehouse is replaced by an integration schema that's business rule neutral. That's what integrates the data from across the enterprise. Then there are various BI schemas with various different technologies that may be instantiated by schemas, a semantic layer, that people can actually access and implement. The lead into all this, the reason why I spent all the time in there, is that usually without the lead in or without discussing it, people just ask, why can't we just use Hadoop? Or why can't we just use a technology? All those technologies are good, but the reason why you have to do this work is because you have to do this work in order to get the stuff out there. And so these slides weren't planning to 10, but just different ways to implement this. These are all online. He's going to do on polyglot databases, just say the leaders, of course, are now being replaced by AWS and Google, with Microsoft and Oracle making great strides. So those will be the databases of the future. Hadoop, Hortonworks, well, Hadoop, yes. Hortonworks, Cloudera, MapR, not so much. All right, architectures, when you're integrating this, the typical traditional BI architecture, you have BI tools, either self-service or guided discovery tools. You're going against these sources using information access. Two other concepts to think about. One is actually creating an environment for data analysts and business analysts, analytical sandbox, for them to be able to create their own data sets, their own dashboards, and be able to publish those to other business people. We've got to the point where we start publishing the dashboards, but we also need to publish the accompanying data sets, because that's just as important, and even more so, than the dashboards themselves. So we need to actually proactively start incorporating technology in order for the data analyst to really be the production factory for much of the ad hoc, much of the analysis out there. 80+% of analysis is one shot ad hoc analysis, that's what they do, and the next 20% that needs to be production-wise, an environment needs to be set up for them to do that. Similar kind of thing with the data science lab, we'll get through that. The last couple ideas is just on the data integration side. So in the past, and I think still people look at ETL, extract, transform, load. We've gone way beyond that in the technology itself. There are hundreds of different transformations and processes and services that are built in to the modern integration platform, whether it's Informatica, Talent, MuleSoft, et cetera, out there. I'm not pushing those products, there's plenty of other great products out there, ODI, et cetera. But each of these provide a set of services that if you don't use the tool, you have to code. And to be honest, most coders don't even know about these services, don't know how to implement these services, and basically you just run SQL scripts or the equivalent of SQL scripts to load data. So, and plus, dimensional modeling, logical dimensional modeling, where you implement any version of a polyglot or multi-model database. The logical dimensional model is what portrays the business relationships in the schema. And both ETL tools and BI tools are built with those constructs in mind. Slowly changing dimensions, hierarchy management, lots of stuff that are built into these tools. So when I teach this in the graduate school, I start off with the data structures, the data models, and then show how they're interrelated to data integration workflow and BI creation. All right, and now let's see. That's it. Let me see. And then just along these lines too, is the other misconception about, first off, the misconception of data integration is ETL, so that's the first thing. Second is that it's just batch. So I can use Informatica, Tableau, Talent, ODI, lots of tools, except for Microsoft, to be able to go to JSON, use JSON, XML, cloud, big data sources, Hadoop, et cetera, out there. So it's no longer just going a batch job against the file and against a relational database. All right, so that's basically my thing in a nutshell. The only other last thing is, even though that's from the Revenge of the Nerds, whenever I show that in class, my students think that's my high school picture, but I'm not offended. But that's what they think. All right, so thanks a lot. If anybody has any questions, you can see me afterwards. I'll be hanging around because we got to get to the next presentation.